A nifty little tool that you'll come to use in the next several minutes is going to be this process called completing the square. And what this allows us to do is figure out what number, what constant can be added into an equation, on both sides obviously, to make a perfect square trinomial. The first thing that's important to note is that a perfect square trinomial means that it is the square of a binomial, x plus a number or x minus a number. So the form is x squared plus bx plus that b divided by 2 squared is going to equal x plus b over 2 quantity squared. This is the process. Now let me show you why this is true. Now the algebra may be a bit staggering because there's fractions involved, but I'm sure that you guys can handle it. So what we're going to do is square this binomial right here. When I have x plus b over 2 squared, it means I'm taking x plus b over 2 times itself. And so this is what we'll do. We'll use the distributive property. I'll take x times this factor pair right here, x times x plus b over 2. And I'll take b over 2 times x plus b over 2. When I do distribution, I get x squared plus bx over 2 and b times x over 2 plus b over 2 times b over 2. Let me just write that like this. All right, b over 2 squared. I'm multiplying it by itself. All right, now this right here, these are like terms. B over 2x's plus b over 2x's makes a total 1bx. So that is why this binomial squared is equal to this form right here, x squared plus bx plus b over 2 squared. So what we're going to do is we're going to try to figure out what number would have to go here, what constant would go here so that we could write an expression, a quadratic expression as a perfect square binomial. So looking on this side, I have x squared plus 12x plus some number is going to be a perfect square. X squared minus 20x plus some constant is going to equal a perfect square. And x squared plus 5x plus some number is going to be a perfect square. These are increasingly more difficult as we move our way down, but I trust that we can handle it. All that we need to do is take this number, this number, this number, and divide it by 2, and that tells us what goes here. We'll take that number divided by 2 and square it. All right, so this number is 12, divided by 2 is 6. 6 squared is 36. So that means that x squared plus 12x's plus 12 over 2 squared, 36, is equal to x plus, what's 12 over 2? We said that was 6. X plus 6 squared. Now, negative 20. Negative 20 divided by 2 is negative 10. Negative 10 squared is positive 100. So, we can rewrite x squared minus 20x plus 100 as x minus 10. That's what negative 20 divided by 2 is. X minus 10 squared. If I multiply that out, I get x squared minus 10x minus another 10x. That's how I get my negative 20x's. And then negative 10 times negative 10 gives me a positive 100. Now here's where it becomes a little bit more difficult. Because when I divide 5 by 2, I don't get an integer. I get a rational number. I get a fraction, a decimal, whatever. When I take 5 divided by 2, that's a fraction. That's 2.5. And 2.5 squared is not going to be too terribly difficult of a number, 6.25. All right? But we're going to leave it in terms of a fraction instead of in decimal terms. All right? Because what we're going to do moving forward is we're going to have to take square roots. And it's easier, well, it's not easy, but it's easier for us to take square roots of rational numbers written as fractions than it is to take square roots of rational numbers written as decimals. All right? So we are going to write this as x plus that number, 5 over 2, quantity squared. And this makes a perfect square. You can check that on your own papers. I encourage you to do so. This is the process for completing the square. You find out what b over 2 is, and you square that. Find out what b over 2 is, and you square it. Find out what b over 2, 5 over 2, and you square it. I'm just writing it like this. I didn't even write it as 25 over 4 or 6.25. I just took 5 divided by 2 and wrote it as 5 divided by 2 squared. All right, and that is how we do completing the square.